Hello and welcome. In this video, we're going to go over the homework for Unit 7, Lesson 2 on inscribed angles. Please remember to pause or rewind the video as needed. Let's begin. Now, in question number 1 is a measurement and construction question that requires the use of a protractor. Some of you may or may not have protractors to use, but essentially what you do is you take your protractor and you put the circle that's right here on the protractor at the vertex where you're trying to measure. So if I want to measure the angle BDC, which is this angle right here, that angle right there, I would take that, this is a circle, and I put it right at the vertex. I would take 0 on the protractor, I would put it right here, and I would measure off this angle right here. And that angle comes out to about 134 degrees when you use a protractor to measure this. Doing the same thing for BAC, which is this angle here, that comes out to about 67 degrees. And that makes sense because BAC is the inscribed angle, where it's the angle that's inside the circle touching the circle. And the inscribed angle is always half of the arc that it intercepts. So since the arc length, the arc angle was 134 degrees, half of 134, 67 is indeed half of 134 degrees. So it does check out. Question 2. In the diagram of circle M shown, the measure of PRQ is 308 degrees. Which of the following is the measure of PRQ? Angle PRQ. So PRQ. So PQ, if you looked at the two arcs here, PQ is the blue one, PRQ is the gray one that goes all the way around, and that's 306 degrees as measured by the central angle. Remember, the arc always matches the central angle, so that central angle is 308 degrees. Now, what that means about PQ, the blue angle would be 360 minus that. Now, what we want to know is we want to know this angle right here, which is PRQ. So we want to know what that angle is. So that angle, PRQ, that is, that is an inscribed angle. Okay, so what do we know about inscribed angles? The measure of angle PRQ is going to be half of the measure of the arc that it intercepts. So the arc that it intercepts would be the blue one, PQ. So let's figure out what measure of PQ is. So the measure of PQ would be 360 minus 308, which would be 52 degrees. Okay, so the measure of angle PRQ is half of 52 degrees, which is 26 degrees. And that would be option 1. Number 3, in circle D, measure of angle CAB is 32 degrees. So this angle here, CAB, is 32 degrees. Which of the following is the measure of arc AC? So I'm going to blacken in arc AC so you can see it. So arc AC is the black arc that I just drew right here. Well, here's what we know. We know the measure of arc CB. Okay, and here's how we know it. The inscribed angle, the measure of angle CAB, which is that angle right there, is half of the measure of the arc that it intercepts, which is arc CB, which means if that's 32 degrees, ladies and gentlemen, then that must be 64 degrees. Now, this is where students kind of have a hard time with this. It's 64 degrees. How can they be two different angles? Remember, guys, it's 64 degrees as measured from a central angle. That is what it's measuring, the same 64-degree angle. Okay, so we know, since we know the measure of angle CB, we can then say the black and the blue together. So arc AC plus arc CB add up to 180 degrees, because that would be half of a circle. So then just subtract that. We're going to go arc AC is going to be 180 degrees minus the 64 degrees, which is 160. Or option 4. Number 4, in circle K shown, the measure of arc NPL is twice the measure of arc NL. So let's color code these so we can see them more clearly. In black, I'm going to mark NL, and in blue, I'm going to mark NPL. So the major arc, it tells us the major arc is twice the minor arc as measured from that angle. So again, if we have a central angle, if you were to have a central angle, this angle measurement and thus this arc would be half of this angle measurement and thus this arc. Okay, so here's what we know. The black and the blue together have to add up to 360. So what we can do is we can let arc NL be X. And therefore NPL be 2X. So therefore, X plus 2X has to add up to 360 degrees. Or we could say X plus 2X or 3X equals 360 degrees. So solving for X, we get X is 120 degrees, which is arc NL. So NL is 120 degrees. That's 120. That's 120. But it also means that NPL arc NPL is equal to 2 times 120, which is 240 degrees. Now, we're not done because that's not what we're looking for, but it helps us along the way, because here's why. We want to know the measure of angle NML. So look at here. Angle NML is this angle right here. It's that angle right there, that inscribed angle. Well, that inscribed angle intersects the same arc as NPL. So here's how we finish this. The measure of angle NML is half the measure of arc NPL, which is half the 240, which is 120. And that would be option 3. Question 5. In the diagram shown in circle A, segments UV and UT are congruent. So UV, this segment here, and UT, that segment there, are congruent. So I'm going to put a little tick mark there to represent their congruence. If the measure of arc VST is 220, let's color code this. VST, that would be this big arc all the way around here. So the measure of that is 220. Now remember, guys, that's measured from a central angle. So if you put in, let's say this right here, this radius and this radius, that angle is 220 just like that arc length. That arc is 220. We want to now determine angle VSU. VSU. So really, we want to find that missing angle right there. Here's what we need to know. That's an inscribed angle, and the measure of angle VSU is half of the arc that it intercepts. And guys, it intercepts this arc right here that I'm coloring in blue, VU or UV, whichever. So we need to find the blue arc. Well, here's what we know. We know that this part that I have here colored in yellow represents the other portion from the 220. So in other words, if I can find arc VT. So arc VT, arc VT is going to be 360 degrees minus 220 degrees, which is 140 degrees. Now, since this line and this line segment are equal, this arc and this arc are equal. So let's make a note of that. So since UV is congruent to UT, then arc UV is also congruent to arc UT. And thus you can take the 140 and cut it in half. And each of those would be 70 units. 70 plus 70 is the 140, right? Okay, so now we're almost done. We remember the measure of angle VSU is half of the arc that it intercepts. The arc that it intercepts is 70 degrees. So half of 70 degrees would be 35. Pretty tricky. Question 6. In circle M, triangle ABC, you can see ABC right here. Triangle ABC has been inscribed. It is known that AB is equal to AC. So this is equal to this, which means it's telling you if this is equal to this angle is equal to this angle, that's an isosceles triangle, isn't it? Well, we'll get back to that in a minute. We also know that DC, this line segment here, is perpendicular to AB, this line segment here. And then lastly, we know that the measure of DCB, this angle right here, is 23 degrees. So we need to find the measure of BDC, that's this angle here. Then we need to find the measure of arc DAC. Arc DAC would go around and be the major arc like this. Okay, so we have some pieces to find, okay? And the way we can start doing this is we can really start using a couple different ideas. One idea we can use is that all interior angles of a triangle add to 180. We're going to be using this a lot right now, okay? So let's actually take a look. Here's the first one. If you guys see this triangle that I'm going to highlight in yellow right here, it's a right triangle. with 90 degrees right there. So if this part right here is 90, so is this, so is this, so is this. And that really allows us to find a lot, okay? So if this is 90 and that's 23, then that means that this angle here, this angle right here is going to be, because if this is 90, these two have to add up to 90. So that missing angle would be 90 minus 23, which is 67 degrees. So we're going to put a little 67 in there. Now, if this, guys, is 67, then that means that this whole angle is also supposed to be 67 because they're isosceles, remember? Two equal sides, two equal angles. But here's the thing. We already know that part of that is 23 degrees. So that means this other angle here would be 67 minus 23, which is 44. Okay. Now, what else do we know? This angle is 44. This is 90. This top angle right up here would be 90 minus 44, which is 46 degrees. So 46 degrees up top here. Okay, now what I'm going to do is I'm going to work my way around the arcs. Okay, here's how I'm going to do it. I know that this angle here, this inscribed angle here of 46 degrees, corresponds to the following arc that I'm going to write in gray. This arc BC right there corresponds to that inscribed angle of 46 degrees. So I also know that that inscribed angle is going to be half of my arc. So my arc is going to be double my inscribed angle, or 2 times 46, which is 92. So arc BC is going to be 92 degrees. So I'm just making notes all over my circle and the triangles, figuring out angles, figuring out what I can. The next thing I'm going to do is I'm going to go to this arc right here. I'll put this one in yellow. I'm going to call this arc AD right here. Now arc AD is going to be double that inscribed angle. Remember, the inscribed angle is half. So double 44 degrees would be 88 degrees. Okay, similarly, this side over here, arc AC. Arc AC is going to be double 2 times. Sorry, it's going to be 2 times the inscribed angle right here of 67 degrees. Which is 134. So I'm working my way around the circle, finding what I can. And I don't know. I do know that this remaining arc right here would be 360 minus 88 minus 134 minus 92. So if I subtract this, this, and this, I will get that remaining little arc right. Okay, so arc BD is equal to 360 minus 88 minus 134 minus 92. And that would be 46 degrees. So what we're going to do is let's just take a look over the measure of angle. The measure of angle BDC is going to be half of its arc. of its inscribed arc. So where's angle BDC? It's this little guy right here. And that little guy right here corresponds to half the arc of BC, which is half of 92 degrees, which is 46 degrees. And then the measure of arc DAC, the whole blue one around, the measure of arc DAC is going to be equal to arc AD, the measure of arc AD, plus the measure of arc AC. That's one way we could do it. So in other words, 88 degrees plus 134 degrees equals 222 degrees. There are other ways to do this. This is just one way. We could also take 36 minus 46, this part right here, minus 92, and we can get 222 that way also. Number 7, in circle E shown, chords AB and CD are parallel. So we have two parallel lines right here, oops, there we go, cut by a transversal. Alternate interior angles are congruent. So just kind of reviewing what that looks like. Angles 1 and 2 are alternate interior. So it tells us, what does this tell you about angle 1 and 2? Well, angle 1 is congruent to angle 2 because alternate interior angles are congruent. And this is, of course, two parallel lines cut by a transversal, creating those alternate interior angles. Part B, given your answer to A, what can now be said about arc AC and arc BD? So arc AC and arc BD. Well, if you reason it out, since angle 1 is congruent to angle 2, then the arc that intercepts it, then arc AC must also be congruent to arc BD because they're intercepted by the same angle. Okay, and then lastly here, fill in the following. Parallel chords, that would be, right, this chord and this chord. Parallel chords will intercept equal arcs here and here. Again, I hope you found this video tutorial to be helpful. Remember to pause and rewind as necessary. Thank you.